Normal procedures. I want to dive into section 4 of the Robinson R22 POH, which covers the normal procedures of operating this versatile helicopter. Whether you're preparing for a flight or performing in-flight adjustments, understanding these procedures is essential for safe and efficient operation. All right, so here's the normal procedures. Here's a list of all of the pages corresponding with all of the normal procedures. This is also includes of like where your flight school gets a checklist. If they have their own modified checklist, they're able to have a checklist that only adds to, they cannot take away from this master checklist. Now, recommended airspeeds, takeoff and climb, maximum rate of climb. You will be asked about the maximum rate of climb, VY. Maximum range, 83 knots, but that is certain conditions may require lower airspeed. See V&E placards in section 2. We talked about that in a little bit earlier. For turbulence, 60 to 70, a placard on section 2 that we talked about. For maximum range and significant turbulence, there's certain conditions may be required, lower airspeeds, like that V&E in the sections 2, the limitation section, along with the auto rotation that we talked about there. So know these, learn these, love these, especially the VY, which is the maximum rate of climb. Daily and pre-flight checks, you got to read through this, understand all of that stuff. Now, this is literally where your flight school has either printed this off and you're using like verbatim this exact checklist, or they have kind of condensed it, maybe changed the font, maybe squished it down, maybe put it on a double-sided thing. But this is literally where they get all of the information from. Do not pull down on the blades, teeter up on the rotors. So this is talking about the main rotor blades themselves. And then the erosion, so on and so forth. Removable controls, some caution, and then so on and so forth. Solo, when you're flying, baggage compartment capacity before using the right compartment, so on and so forth. Shorter pilots may require a cushion, but you get the idea. I like to go through and just kind of read the cautions because I assume that your flight school and you are going to be familiar with their or this checklist. But these cautions may or may not be printed on the checklist. So low RPM horn throughout the audio system, a headset for each pilot is required. So unless there's an actual speaker for the low RPM warning system, you have to have a headset. Avoid continuous operation at rotor speeds of 60 to 7 to minimize tail resonance. On slippery surfaces, be prepared to counter nose right rotation when the left pedal as governor increases RPM. So now takeoff procedures, here's the, lights, camera, action type of thing, and then cruise. In turbulence, it talks about this, extreme care, inadvertently pull mixture. That's where we, go around with your left hand, go around the left side of the stick. Inadvertent leaning of the engine mixture controls is not recommended. I had a question once, a fascinating question that somebody brought up to me that was talking about if you inadvertently pulled the mixture, but you put it back in, would the engine remain running and would you be able to be okay? My answer to that is you can test this on the ground. I would not recommend this, but the idea is don't ever test this during flight. On the ground, add flight idle or something like that. You could pull the mixture and push it back in. What's going to happen and why you shouldn't maybe test this is because the engine may stop for a second and then kick back on. It may completely just stop and it'll be fine. But what happens is the jarring motion of like either sputtering or stopping and then like coming back to life. As the engine is decreasing in RPMs, but then mixture is added and the spark's already there, it may jolt back to life. So on the fan squirrel cage behind the R22s and the R44s, a sudden increase in engine RPM in a rapid small manner or sudden stoppage may cause the fan scroll to become unbalanced because it's balanced given its relative clock position to the engine output shaft, right? So what happens is there may be a disconnect between those two. And yeah, there's a cotter pin, there's a whole bunch of like, safety, they call it safety line, and then also the paint that they put on there. But there may be a jarring motion. So I would not recommend this, but talk through it with your instructor. But my hypothesis is if you were to inadvertently pull the mixture and push it back in quickly enough, you may get the engine started, which is fine if you're over water, but in reality, don't pull the mixture. Like here's an idea, don't pull the mixture, okay? Doors off operation. Can we do it? Different flight schools have different regulations that are above and beyond this, but here's what it says. In order to do it, you have basically watched the loose objects. And then obviously you need to keep your head and arms inside to avoid that airstream at speed. However, you can stick your head out, but I would recommend it. Practice auto rotation, power recovery. And then they continue this. Simulated engine failures require prompt lowering of the collective to avoid dangerously low rotor RPM. Here's something that you're going to need to know. 80% plus 1% per 1,000 feet of altitude. He may ask you, or she, the examiner, or your instructor may ask you, at what point in time does the rotor RPM actually stall? And it's literally 80% plus 1% per 1,000 feet. So if you're up at 3,000 feet, it's going to be 83%. Okay. This is where they're getting the information. Practice auto rotation with ground contact, meaning full down. These are, kind of going back and forth in between. The flight schools do them, and then the examiner doesn't want to do them, but you get a sign off. And in my day, it was you do them with the examiner during the check ride even for private guys. But then they balled up a number of helicopters, so they've kind of gone away. But anyways, understand some of these cautions and notes. Use of carburetor heat. You will be asked this on the check ride. You will be asked this as part of the flight school. Every flight school is going to have their own independent procedures that are above or beyond this. But know that carburetor ice can form in a wide range of atmospheric conditions, but most likely from when the outside air temperature is between -4 degrees and 30 degrees Celsius. So 25 degrees Fahrenheit and 86 degrees Fahrenheit. What do you think? Like beautiful 80 degree day. Like how am I getting carb ice? Well, the difference between the outside air temperature and the dew point is less than 15 degrees Celsius. When these conditions are conducive to carburetor ice as suspected, use carburetor heat as follows. During engine run up, full carb heat. Takeoff, climb, and cruise as necessary to keep the gauge out of the yellow arc. Descents and auto rotations, high, below 18 inches manifold pressure, full carb heat regardless of outside air temperature. So if you're practicing autos, just leave the carb heat on. The pilot may be unaware of carburetor ice. Formation of the governor will not automatically increase throttle or maintain constant manifold pressure and RPM. Therefore, the pilot must apply carburetor heat as required whenever icing conditions are suspected. And then here's some carb heat assist with the R22s with the 0360 engines. Here's some information about that. And then descent, approach, and landing checklist. Caution when landing on a slope, return cyclic control to neutral before reducing rotor RPM. Never leave helicopter flight controls unattended while engine is running. Meaning you cannot stop by the 7-Eleven, leave the helicopter blades turning, hop out and grab a beer, and then hop back in. You have to shut the helicopter down. Hold throttle closed if the passenger is entering or exiting, or when the engine is running, the left seat collective is installed. So be weary to guard the controls if they are installed. And then the shutdown procedure. And then it talks about ambient temperatures above 100 degrees Fahrenheit or 38 degrees Celsius. Cool down at 70 to 75% for at least 1 minute prior to reducing to idle. Remember previously, what's that RPM range that we don't want to, we want to avoid, we don't want to stay in, which is 60 to 70%. So 70 to 75%, is a little bit less, but, make sure that you're avoiding that other RPM range as well. During idle and after engine shutdown, pilot should uncover one ear to listen for unusual noises. So like bearings, we have a bunch of bearings on the R22, and the bearings will give an audible, something just doesn't sound right prior to them failing, catastrophically failing. So bearings, and then also the teletemps on the bearings will help, but not always. Don't slow a rotor RPM by raising collective during shutdowns. All right. Very important. All right, let's talk about some noise abatement. This is basically to fly courtesy, fly safe. We, hear some information about where we should, how high we should, and then also understanding repetitive noise is far from irritating than that single occurrence. If you must fly over the same area more than once, vary your flight path to not overfly the same buildings each time. Now the big caveat with this is like, if you're in a like downtown LA, like, and you have no choice but to always fly over the Bank of America building on First Street, like whatever, it's fine. Like in city situations, you can't help it a lot of times because you're limited on where you can fly and the routes that you can fly because of VFR reporting points and understood local procedures. However, if you're out in this the boondocks or out in, you know, suburbia, and you're always flying over, you know, your girlfriend's house, your girlfriend may like it, may not like it, but also like the neighbors may not like it. So fly courteous, fly safe, fly nice. Okay. Okay, so this last little section over here is information per the FAA AD 952604. This is the SFAR 73 stuff, plus some information about main rotor stalls, mass bumping, and then to avoid these conditions with strong winds and whatnot, 60 knots in less than 0.9 VNE, but no lower than 57, maximum power on, avoid side slip, you know, avoid large rapid forward cyclic inputs, you know, so on and so forth. All of that stuff that we've talked about before. Understand by adhering to these principles and the normal procedures, we can ensure that the safety and efficiency of our flight operations. If you have any questions or need further assistance or clarification on any of these procedures, feel free to reach out to me or to your local flight instructor. Fly safe. If you love the overly technical lessons and the dry humor here on YouTube, you'll absolutely love my online helicopter ground school. I'll walk you through everything you need to know to become a helicopter pilot, minus the sarcasm. No, actually not. Yeah, there will be sarcasm. Head over to 3gheliprep.com and get started today.